Dr. Kanbir from Math Topia Academy.
Hello, and I am Ava Kumar, peer teaching assistant for Transition to Algebra at Math Topia Academy.
We will be solving first 15 problems from 2020 AMC 8. Let's start the first problem.
Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He used 3 cups of lemon juice. How much water does he need? So he used 3 cups of lemon juice. It says he needs twice as much sugar as lemon juice, so twice as much. This means he needs 6 cups of sugar. For water, he needs 4 times as much water as sugar, which means you'd multiply the amount of sugar by 4. You get 24.
Thank you, Eva. This problem, some level a little bit challenging because the second sentence, right, Eva? It is hard to process this sentence, right?
The language.
Language, that's correct. But you did a great job to explaining. That's great. That was the problem 1. Let's take a look at problem 2.
4 friends do yard work for their neighbors over the weekend, earning $15, $20, $25, and $40 respectively. They decide to split their earnings equally among themselves. How much will the friend who earned $40 give to the others? First, let's see how much each friend gets. To do this, we add the amount of money each friend has, and then divide by 4. 15 plus 20 plus 25 plus 40 is 100.
You are trying to calculate, you are getting average, right?
Yes, I'm calculating the average. So we added up the amount of money. Now we divide by 4 for the 4 friends. Each friend gets $25. So friend 4, he had $40. Now he's going to get $25. So he has to give away $15, which is C.
That's good. Then maybe friend 1 receive how much money?
Friend 1, he gets $25, but he had 15. He will get plus 10. He'll get $10.
Friend 2.
Friend 2 will get $5 because he had 20.
And
friend 3 will not get or lose any money. He already had $25.
Good. Very nice explanation. Thank you. So that is okay. Let's take a look at problem 3.
Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. She is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? Here we have a 6 by 8 garden. 6 times 8 is 48, so the area of the garden is 48 square feet. Each one of these squares here has 4 strawberry plants. So to see how many strawberry plants her garden is, we multiply 48 by 4. This is 192. Now, each plant has 10 strawberries. So we multiply 192 times 10, which gives us 1,920, which is how many strawberries she can expect to harvest.
That's very nice. We could also do 4. Each 4 goes to 40, right?
Yes.
And we do also that way, 40 times
40 times 48.
That will
which would give us the same answer.
That's good. So, okay, let's take a look at this pattern growth one. That's nice. It looks nice problem.
Let's see. 3 hexagons of increasing size are shown below. Suppose the dot pattern continues, so each successive hexagon contains 1 more band of dots. How many dots are in the next hexagon, the 4th figure? Well, we can notice a pattern. Hexagon 2 has 2 dots plus 3 dots plus 2 dots. 2 plus 3 plus 2 is 7. Hexagon 3 has 3 plus 4 plus 5 plus 4 plus 3. This is 7 plus 7 plus 5 is 19. So hexagon 4 should have a similar pattern. Since hexagon 2 started with 2 dots, hexagon 3 started with 3 dots, we can predict hexagon 4 will start with 4 dots. We'll have 4 plus 5 plus 6 plus 7 plus 6 plus 5 plus 4. Adding these numbers up, we get 37, which is B.
Thank you, Eva. This is very nice visual approach. Then, so we can see that 1 plus 6, right?
Yes, 1 plus
Then
12.
1 plus 6 plus 12, right?
Yes. And then figure 4 will have 1 plus 6 plus 12 plus 18.
The next one would be 1 plus 6 plus 12 plus 18.
Mm-hmm.
But yours is, I think, that very visual and makes sense. It's better to explain that way, visual. I like it. That's very nice. So let's go to number 5. The rate and ratio problem, a percent problem. When we have rate, ratio, and percent problem, you could use any number you like to do. So let's see, Eva, what number are we going to use? Let's see.
Okay, first I'll read the problem. 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? What number should we use, Professor?
So first, we are going to shade. Are we going to shade 3/4, right?
Yes.
This part. So we are going to shade this part. I am thinking since everything is 5, why don't we put 5 for each section?
That's a good idea. Mm-hmm. So if each portion of this was 5, the total capacity of the pitcher would be 20, but only 15 is full. So 15.
Mm-hmm. 15 of them will go to where? 5 cups. Equal.
Yes. So if 15 goes to 5 cups, each cup will get 3.
Mm-hmm. 3 liters of whatever measure we have, right? Good.
Yeah. So what percent of the total capacity of the pitcher? Well, the total capacity of the pitcher is 20, and each cup received 3. So we have 3 over 20. To turn this into a percent, we need the denominator to be 100. So we multiply by 5 over 5. We get 15 over 100, which is the same as 15%.
That seems very understandable. Yep, I like how you made 100%, because out of 100, you got 5 times 15 over 100. So let's see this problem.
Aaron, Darren, Karen, Marin, and Sharon rode on a small train with 5 cars that seat 1 person each. Marin sat in the last car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron, and at least 1 person sat between Karen and Darren. Who sat in the middle car? Well, the first clue we get is that Marin sat in the last car. This shows us that Marin must have sat right here. Now, Aaron sat directly behind Sharon. Well, if Aaron sat here, Sharon would sit there. But Aaron could also sit here, and then Sharon would sit here. Or Aaron could sit here, and Sharon would sit here. There's 3 different possibilities. Let's see which one of these 3 possibilities works. Well, This possibility would not work because it says that Darren sat in a car in front of Aaron, but here only Sharon sits in front of Aaron. So we can eliminate this possibility. At least one person sat between Karen and Darren. Well, let's try one of these two possibilities and see if we get a contradiction. Say we have over here. Well, Darren would sit in front of Aaron. Darren could sit here or here, and then Karen would sit in the other one. But these two possibilities, they do not work because Karen and Darren are right next to each other. So Aaron and Sharon cannot sit here. How about Aaron sits here and Sharon sits here? Well, this would work because Darren sits in front of Aaron, so Darren would sit here, and then Karen would sit over here. And yes, Karen and Darren, at least one person sits between Karen and Darren. All of the criteria is met with this example. So we see Aaron is sitting in the middle car.
Okay, that is a very nice explanation. I think it satisfies all the conditions, right?
Mm-hmm. All of them.
That's great. Number 7.
How many integers between 2020 and 2400 have 4 different digits arranged in increasing order? This may look like a hard problem at first because we see, oh, there's many numbers between this number and this number. But really, when we think about it, well, what numbers would not work? How about numbers in the 2000s, greater than 2020? They will not work because 0 is less than 2. This is not an increasing order already, so we can eliminate numbers in the 2000s. How about 2100 numbers? Well, 1 is still less than 2, so numbers that are 2100 won't work either. How about 2200? Well, it's still not in increasing order because 2 and 2, it's not increasing. So really, the only numbers that could work are 2300. Now, the 4th digit could be it couldn't be 1, 0, 2, or 3. It could be 4, 5, it could be 4, 5, 6, 7, 8. It can't be 9 because there wouldn't be any digit after 9 that's greater than 9. So it has 5 possibilities. 5 possibilities. How about if now the third number was 5? There would be how many possibilities? Well, there could be 5, 6, 5, 7, 5, 8, and 5, 9. That would be 4 different possibilities. How about if the third number was 6? Then it could be 6, 7, 6, 8, 6, 9. 3 possibilities. If the third number was 7, it could be 7, 8 or 7, 9. 2 possibilities. And finally, if the number is 8, it could only be 1 possibility, 8, 9. So 1. These are the only possibilities. So we add them up and we get 9 plus 3 is 12 plus 3 is 15. So 15 integers satisfy the conditions.
You made this problem easy by working those cases carefully, right?
Yeah.
Because when we go structural, right, when we go to case by case, it help us to organize our data, right? That's the case you did this way. I like
Some
it.
cases don't work, as we discovered.
Good. Perfect. Now, problem 8.
Ricardo has 2020 coins, some of which are pennies, 1-cent coins, and the rest are nickels, 5-cent coins. He has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest amount and the least possible amount of money Ricardo could have? Well, first let's think about what's the greatest amount of money he could have. Since nickels are worth more cents than pennies, it would be he can't have 20 nickels though, but he would have as many nickels as possible. He could have 19 nickels at the most, since one coin has to be a penny. This would be the greatest amount of money he could have, which is 2019 times 5.
Times 5.
10,095 plus 1 penny. So the greatest amount of money he could have is 10,096.
This is the greatest amount. That's great. So let's take a look at the least possible amount.
The least possible amount, on the other hand, would be having as many pennies as possible and only 1 nickel. So that would be 2,019 pennies and then 1 nickel. That is 2019 times 1, so 2019 plus 5 cents, which is 2024. This is the least amount he could have.
So what are we looking for now?
The difference in cents between the greatest and the least. So what we do is we subtract these. And we get 8,072.
That is a great solution. Thank you. Nice. Problem number 9.
Akash's birthday cake is in the form of a 4 by 4 by 4 inch cube. The case has icing on the top and the 4 side faces, but no icing on the bottom. So the cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch, as shown below. How many of the small pieces will have icing on? Exactly 2 sides. No more than 2, no less than 2. Well, let's see. We can eliminate these corner squares. These have icing on 3 sides, 1, 2, 3. So it won't be any of the corner squares. Well, actually, hold on. The bottom corner squares. Yeah, Professor, it also won't be these because on the other side.
Correct.
But the bottom ones, actually, they do have icing on only 2 sides because, remember, there's no icing on the bottom. So I will put these in green because they count. These. Oh.
Yeah, that's okay. These.
Okay, let's see. Do these work? Well, yes, it only has 2 sides, so these work, as well as these. And these also have 2 sides too. These, though, these don't work because they only have 1 side. So on one face of the cube, we have 2 plus 3 plus 3, 8 pieces that have icing on exactly 2 sides.
Front, right?
On the front. Now the same applies to the back face, the face we can't see in this picture. It'll be exactly the same idea. So it'll also have 8. So we multiply 8 by 2. 8 times 2 is 16.
Good.
Now,
are we done yet, or?
We're actually not, because if you see these 2 cubes on the side, they also have 2 faces of icing, as well as these 2. So we have 4 more cubes that fit our constraints, and so we get 16 plus 4 equals 20, which is D.
So looks great. So 20 total, 2 sides. So let's say number 10. Ava, if we have four different objects, let's say, yeah, can you read out the question, please?
Yes. Zara has a collection of 4 marbles, an Agi, a bumblebee, a steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put the steely and the tiger. Professor does not want to put the steely and the tiger next to each other.
Does not want, right? That's good.
Yes.
Good.
In how many ways can she do this? Okay. Well, a way to think about this, we could solve for the ways that the steely and the tiger are next to another, but then subtract from the total amount of ways.
So if we have not any condition, A, B, S, T, how many different arrangement we can make A?
It would be 4 factorial because it's 4 4 times 3 times 2 times 1.
24. Now, what is the constraint? So we have a condition.
You don't want the steely and the tiger next to each other.
Let's think first. Complementary counting. That means let's think opposite. Why don't we put S and T together?
Yeah, we can do that.
Then now this case, how many different objects we say? 1, 2, 3, right?
3 factorial then we could say,
but
which is 3 times 2 times 1.
Can S and T switch?
Yes, this would also work. So you do 3 factorial times 2.
Which is?
12.
12 is they do together, right? S and T together. And how do we complement this one? 24 minus.
Which is also 12.
12. In this case, it adopt it's coincidence, right? It adopt the 12, but it's a good complementary counting problem. Yeah, good example. Thank you. So let's see. Very nice data graph. Let's see.
After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi and Maya's average speeds? Let's see first how much Naomi's speed would be in miles per hour. Well, Naomi, she traveled 6 miles in 10 minutes. So in an hour, we'd multiply both of these numbers by 6. We get 36 miles for 60 minutes. Now, Maya, on the other hand, she had 6 miles in 30 minutes. So in an hour, multiplying both numbers by 2, she'd have 12 miles in 60 minutes. So these are the girls' average speeds. So now we find the difference. Well, Naomi's was 36 and Maya's was 12. So we do 36 minus 12 equals 24.
Yep, that was the problem 11. Now, let's take a look at problem 12, factorial problem. So.
For positive integer n, factorial notation n factorial represents the product of integers from n to 1. So as you can see, 6 factorial here. What value of n satisfies the following equation? 5 factorial times 9 factorial equals 12 times n factorial. Well, the first step we can do is getting n factorial by itself. So we can write n factorial as 5 factorial times 9 factorial. We divide both sides by 12, so it's over 12. Now, let's not expand everything in the numerator yet, but we can expand 5 factorial. We get 5 times 4 times 3 times 2 times 1 times 9 factorial over 12. Well, we see that the 4 times 3 is 12 in the numerator, cancels with the 12 in the denominator. So we get 5 times 2 times 1 times 9 factorial. 5 times 2 times 1 is 10. So we get 10 times 9 factorial, which, very interestingly, it's 10 factorial because it's 10 times then 9 times 8 all the way to 1.
That is equal to 10 factorial.
So n factorial equals 10 factorial. So n equals 10.
Okay, great. Now let's take a look at this problem. Can you read the problem, Ava, please?
Yes. Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add?
So, Ava, let's put X amount of purple socks to the purple this section, right? 18 plus X. Let's see. Do we still have 6 green?
Yeah, he doesn't add any more green or orange socks.
We have 6 green. Do we still have 12 orange? So chance, right? Let's say how do we say, what does that mean, chance? 60 over 100, right?
Yes.
That is equal to what, Ava? So how do we see that? What is the chance? What's the probability of getting purple?
Well, we could write it as how many purple are being added to the original amount over how many socks are being added to the total amount, which is 36 total socks. It would
So
be 36 plus X.
we have the desired amount, 18 plus X, then total amount,
36 plus
X. So that is the, then can I do some simplification here, Eva?
Yeah,
it's going to be,
you could make it 3/5. Yeah, and then it'd be easier.
Then
we cross multiply to solve the equation.
That is the better way to do that, cross multiplication. And I am going to move here to explain here that. So should I do 5 times 18 plus X equal to 3 times
36
plus X?
Mm-hmm. You distribute in the 5.
What's the 5 times 18?
90 plus 5X.
90 plus 5X.
Equals 108 plus 3X.
108 plus 3X. Then we
5X equals 18 plus 3X.
90 plus 2X equal to 108.
2X equals 18.
Then
X is 9. Okay. So he added 9 purple socks.
That is nice, understandable. We use algebraic manipulation, but it's also understandable, right? So, great. So another data problem, visualization. Okay.
There are 20 cities in the country of Newton. Their populations are shown in the bar chart below. The average population of all the cities is indicated by the horizontal dashed line. What's closest to the total population of all 20 cities? Now we need to see what is the value of this dashed line. Well, we see that this in the middle here would be 5,000. This right there would be 4,050. And since this horizontal line, this dashed line, is right between these two values, we can assume it's 4,000,
4,750 maybe.
Yeah. Sorry, this is 4,500 over here. 4,750 would be the value of this dashed line.
That's great.
And now, since it's asking the average population, well, it says the total population, and it gives us the average. We can just multiply 4,750 by 20.
Closest, right? Double of 4,000. That's going to be 95,000. So that's very nice. Then we are moving to our session's last problem, 2020 AMC8 problem 15.
Suppose 15% of X is 20% of Y. What percentage is X of Y? No. What percentage of X is Y? It's important to note the variables here. So we can write this statement. We can represent it with decimals. 0.15x equals 0.2y. This gives us, solving the equation, that x is 20 and y is 15. So we want to find what percentage of x is y. That means y over x. So 15 over 20. Now remember, to get it into percentage form, we need to get the denominator equal to 100. So let's multiply by, which gives us 75 over 100, which is 75%.
Yep, it looks good because you picked the x equal 20, y equals 15. That makes sense.
easier values.
Mm-hmm. So that is end of our first 15 problems solution session. If you want to see some of Math Topia Press materials, you can check the mathtopia.com. And recently there is a two book published. One is Middle School Challenge, one is High School Challenge. If you want to prepare yourself AMC 8, 10, and 12, these books, recent books, would be very useful. Thank you for listening and following the solutions. Thank you.